I want to say a few words about how we chose the best paper. The public was invited to contribute papers which were presented as posters, which you see here. Each paper was reviewed by each organizer reviewed at least two of the papers, and then the organizers were able to nominate one of the papers that they reviewed as a best paper. Then those nominations were passed around to the rest of the committee, and there was a concurrence. And I'm happy to announce that the best paper was awarded to Nicholas Reinhardt, Rowan McAllister, Chris Gattani, and Sergey Levine from CMU and from UC Berkeley. And I want to just read you the posters up there right now. It's Precog, Predictions, Conditions on Goals in Visual Multi-Agent Scenarios. And I want to read a little bit from the text of the review. This work addressed an important and topical challenge in autonomous driving. It nicely weaves together a number of recent concepts from deep degenerative modeling and environment prediction for situational awareness and planning. The evolution is comprehensive in terms of outperforming relevant benchmarks. So I want to invite the presenters to come forward, and you can, just one, you don't have to share the GPU.
Yeah, it's all mine.
Congratulations.
Very much.
Enjoy. Okay, thank you. Now we're going to have a panel discussion, and I would like to invite all of the speakers to come up, and I guess we have some. So the first question that I'd like to pose to the panel is one that we heard some answers to, but I'd like to get everybody's take on it. When can we expect to see level 4, level 5 deployed with whatever constraints you feel are necessary? We just saw there was a comment by, I guess, Chris Ernstrom in the last week or so that he's looking at 30 years. Other folks said 16. Some people think Elon Musk said this next year. So
vision-based, vision only.
Vision only, of course. Okay, so maybe Wilfred, you want to start and
Yeah, that's a good question. I think as always the answer is it depends, and I have a couple of aspects, not too long. I make it short to say about this. So there's always the opportunity to engineer the environment, and if you do that, then it might even be possible in a very few years, having level 5. I think level 4, level 5 is maybe 30 years or 40 years. I'm not going to experience that in my life, I think. I mean, if you don't engineer the environment, then it might be a little bit further along the way. We have seen the statistics today when we count those from Waymo, 0.1 per 1,000 miles, which would mean that we can drive like 10,000 miles per intervention. Human performance is approximately 70,000 miles, so we need a factor of 10 there on top of that what we have already. I do not know how long that's going to take, but maybe a couple of years.
Yeah, I'm personally much more positive. Let's define what do we mean by level 4. If level 4 means we have a large-scale commercial deployment, let's say that more than 1,000 vehicles and commercial deployment without any safety driver, that means level 4. Then I believe it's achievable within 4 years. It's probably 3 to 6 years if I have to put a number. The reason I say this is really because we're not going to have level 4 autonomy, self-driving car driving everywhere at the same time at massive scale. But for some places, for some cities, for some particular applications, things could get easier, and things could be get more mature. One thing is we can change the infrastructure. Right? I point out one example. Right? One of the perception difficulties is that you have some bushes, some tree bushes right next to the road, and from time to time they grow bigger and bigger, and they have a few branches going out. It's very difficult that you can recognize, is this a person, or is it actually an object, or is it an obstacle, or is it a goal. So this kind of scenario, but it's such a difficult problem technically, but it's such an easy problem for the city. You just need to make sure somebody every day go and cut them. Yeah, right. So if you are allowed to have some kind of collaboration with the city government, with the infrastructure provider, things get much easier. A lot of people demonstrate that in China, jaywalking is really a huge problem for traffic, not only for self-driving car, but also for non-self-driving car. Jaywalk sometimes cause the traffic to slow down, cause traffic accident so much. But it's such an easy problem to fix. You build barrier, you build metal barrier that's 1.5 meters high. Suddenly, nobody can do jaywalking. So I would say that it really depends. If you can really do, I would say, again, the definition is more than 1,000 vehicle commercial uses without any human driver. I totally believe that it is to be achievable in 3 years if you work hard enough. If we don't work hard enough, maybe 4 to 5 years. Thanks.
Anybody in the front row want to pick this up?
I would like to, so from my perspective, I think because we are scientists, we should be looking at data. And I think for this question, maybe or like trying to read the stars or the wind, that's a bad answer. So I think we have failed because we haven't been working on putting together the right tooling and infrastructure that we need to try to solve that answer. Like when someone asks something as simple as, hey, how long is it going to take for level 4 in this city, and you are not able to give an answer, it's basically because you don't have the tools, you don't have the infrastructure that you need to share the results between the community to get the global picture that can lead you to an answer. What we are doing is reading the wind. So we need to come back home, start working on putting together the right infrastructure to share this data. We need to start sharing this data. We need to have calibration in the reports that companies submit to NHTSA. When we have that, then we will start like considering to give a proper scientific answer to this question, because in the end, we are still scientists. So we read numbers, we analyze data. We just don't come up with random answer for convincing VCs. That shouldn't be our work.
I think that's actually a great point. And maybe just to add to that, maybe one possible explanation for that is that a lot of us have very different approaches towards this problem. So it's hard to have a centralized tooling where we can compare all of these approaches to that same effect. And said differently, well, even if we had that tooling, it's not clear that the optimal approach is the one that's going to take the shortest amount of time. There are other factors that we would often need to consider when building an autonomous vehicle system or a platoon of autonomous vehicles. Besides just how quickly can we achieve level 4, there's also safety considerations, the amount of infrastructure changes, the amount of money that those infrastructure changes would also need. And me personally, I think that if we just want to approach this problem from the aspect of time, infrastructure changes would definitely be the optimal approach to accomplish this. And it would also actually, I think, simplify the safety problem as well.
I can ask a question. So we've seen a lot of different approaches, as Alex mentioned, and all of them are working towards like larger scale. And machine learning is, as by definition, learning from experience. We've seen like sources of experience include labels, includes disengagements, many different things. What do you think is the best source of information, the best bang for your buck in terms of learning systems? And do you foresee like quantity of a lesser source is better or quality of a smaller source is better? We've seen kind of the spectrum over all these talks. So are you more in the large scale noisy demonstrations or small scale very high quality labels? So what is the best source of experience for self-driving cars?
I'm totally on the small scale side, although we have so much data. I mentioned by the end of the year, we will have more than 100 vehicles collecting data. And right now, even now, we have more than 20 vehicles collecting data. But again, data, I would say in self-driving car, the data is very different because there are a lot of raw sensor data. If you're just considering the raw sensor data, it's so easy to collect a huge amount of data, so huge that even your hard drive in the server room cannot host. So I would say that it's more important you have good data because those data will provide you a lot of feedback. The reason I totally agree with our colleague from Aurora that the reason why we do road tests is because the system is not perfect. You want to expose the problem. Only when you expose the problem, only when you have this engagement, you can fix the problem and then you can improve your system. So it's very important that we don't want to run into a game that everyone trying to have no disengagement. While your system is not perfect and you are trying to have no disengagement, that means your learning rate is really, really slow. So it's very important, part of the reason why we insist on doing testing in downtown metropolitan area, because the downtown traffic is complicated, crazy enough, that can help us to expose those problems as quickly as possible. And those data are the most valuable data. And that's why I totally on the opposite side that we should have certain scale of the data, but it should not go that big because simply those data require engineers to do triaging, to do analysis, and as well as machine learning requires certain supervision of labeling. So up to a certain point, you cannot go more than that scale, no matter how much money we spend. So we need to make good use of those good data. That's to me, that's certainly more important.
Anybody in the front?
Yeah, so I second the answer in that there's often a misconception that large volumes of data are extremely useful. It's really the interesting data that helps you learn the support vectors, right? So I guess your first question as to sources of learning data, training data, that there's no reason to have this dichotomy of should we do supervised learning or reinforcement learning or imitation learning. I think these are all tools in the basket, and we should pick the ones that are appropriate. And our experience has been that they all have their roles to play in getting high performance systems, and we should judiciously use different aspects of learning for solving this problem.
Yeah. Also, I think one of the issues we need to be aware of is what kind of tools do we have to evolve whatever mechanisms we have for gathering data going forward. So we need to take into account all the new cities that we want to scale into, all the new issues, new weather phenomena, or all those kind of things that we want to deal with, and a choice of our algorithms as well as what kind of labels to the question of whether high quality or more quantity really is determined by what kind of scalability we are looking for over there. So for instance, if we have a high quality perception labeling mechanism, but it cannot clearly scale to gathering data in a new city or a new environment which needs completely new labels, then clearly we need to invest more in semi-supervised learning or methods which can exploit more of the existing labels to maybe apply transfer learning to the new cities first, and then somehow help the labelers generate more labels as well as improve the quality of labels which could be generated more automatically.
So I wanted to ask another question. If we look at where many folks are right now in the industry, typically go, at least in, say, highway driving, go hundreds of kilometers without an intervention. And my supposition is that if you can go that far, that's good enough for level 2. If you got much better than that, let's suppose you could go to 30,000 miles without intervention level 2, that might make it even less safe because you're tempted to basically assume the car can go anywhere, and then you could go to sleep or whatever, and then wind up driving, into the back of a truck or killing somebody. So the question I wanted to pose, assuming that we have the technology right now to do massive deployment of level 2, would such deployment be a good idea?
I mean, I can say something with respect to this because we are working on that what is called Guardian application, where we are basically also looking into driver state monitoring. And this is actually something that has been a little bit neglected by the entire car companies, included TRI as well. So regarding the logistics of a real mass application, right? So there's one aspect is if you really want to have like people sitting in the cars, and you also need to know what they are actually doing in the cars while you are driving them around. and what is happening in the car. There's some trivial things like, for example, is the car still clean after the customer left when there's no one in the car to actually check that, and you do not want to arrive for the next customer and your car is a big mess. So these are really hard things that companies actually didn't really think about, and also the logistics of cleaning cars, like when after having performed a service, and so on and so forth. So these questions are really difficult, and the same is true for level 2. For that, you actually would need to have something like driver state monitoring in order to figure out as to whether it's actually in the current situation safe to disengage and tell the driver, hey, it's your turn right now. So you actually need to be able to know what the driver is doing in order to actually have a safe handshake between, oh, sorry, I can't handle this, and the driver actually being in the need of taking over.
Anybody?
To me, that in terms of level 2, I think there's 2 types of level 2. One type is the human taking control. Is like guardian. The machine is watching. If there are any problem, the machine take into action. That's one type. The other type is like Tesla approach. Is like the machine is in control. If the machine has some problem, human get into intervention. So for the Tesla kind of problem, everyone knows that like Tesla, although we can drive autopilot very smoothly, but it does increase some accident because some people lose their guard. That's why the other approach that the human is in control, the machine is just helping to check as a guardian. That's another approach. But personally, I also have a friendly challenge. I also quite skeptical this could work. One thing is really, because everyone here is a scientist with background with technical, think about this. For example, object detection, it will have false positive. There's a ghost object there. There's actually no object there. But what happens now, the computer, if they have false positive, recognize there are ghost object there, then the computer may have to hit the brake because you are hitting into something that is actually nothing, it's just empty air. Then what to do? Should we trust the computer or should we not trust the computer? If we trust the computer, it will drive the car normally, and suddenly the computer will just intervention and hit a hard brake, and then there may be another car behind you that causes an accident. So I would say that one thing is you tune the precision to be extremely high, but the false positive to be very low. But in that case, then the computer is almost useless. Okay, even if you run an accident, the computer may still don't feel comfortable to take over yet. So I would say that that's going to be also a line that is very difficult to draw for the engineer. Somebody have to make that threshold. Deciding that threshold is going to be an extremely challenging scenario for this kind of level 2 guardian system. I would say that if you make super trivial, that's what happened today in most cars. A lot of cars today, they have AEB, they have lane departure warning. This kind of things is okay. But if you really want the computer to take in control, to actually apply the brake or actually to turn the steering wheel, whether that modality is a good application, it is still up for debate.
Yeah, I would like to actually just add on a quick point to that and actually say that I think there's a third level or section of level 2 autonomy where you have shared control and not binary control, where the human is in control predominantly, and then the autonomous system has to jump in and take over control. So at MIT, for example, we have parallel autonomous systems where the human is most of the time in control, but the autonomous system is always kind of injecting torques into the steering wheel angle to inject its own type of knowledge, or inject its own type of autonomy or control into the situation as well. And the benefit of these types of systems is that it tackles a lot of the challenges that Professor X was talking about, wherein you don't need to decide this threshold, which can be extremely difficult to decide in practice. And instead, you can actually leverage model uncertainty, or how certain your model is of certain types of things that it's detecting in the environment. For example, these ghost cars or ghost obstacles that it may not be completely confident of that they're actually there. And these can be also brought into the equation before actually completely taking over control 100%. You can have shared control, and there's a middle ground there that we should also consider.
Microphone.
Thank you.
So my question is about the self-driving cars, the path planning. So in order to make this question clear, so let's think about this like a simplified environment, such that the path planning has only two dimensions to consider. One's being selfish, the other is being altruism. So in this case, on this Pareto curve, what do you think the self-driving car should behave in the following two scenarios? Number one is the human self-driving car hybrid. The second is the just self-driving cars. Because, for example, if you see this morning's video by Dorsa, the Waymo car, the poor car have to go back to the ramp, and because he cannot get in there. So I think the passenger on this car will be really mad if that thing happens, especially if they have to pay for that service.
Someone like to take that one?
So I guess if I understand your question right, the question is, well, how do we tune our system so we get natural human behavior? And I think the answer already is there in the human driving behavior. So we look at how humans drive and we imitate that. They solve these complex problems of how much altruistic or selfish should I be, and we try to mimic that. So the answer in some sense already lies out there.
I want to jump in and just complicate the question a little bit more. That one of my favorite examples is trying to make a right turn going south on Fifth Avenue onto 34th Street, which is the southwest corner of that is the Empire State Building. So you typically have maybe 50 or 100 tourists on the north side crossing over to the south side in front of the Empire State Building. On the other hand, 34th Street is also essentially the gateway to the Lincoln Tunnel to New Jersey. So if you're on Fifth Avenue trying to go south, go on to 34th Street, the light changes and you have this horde of people crossing. And in New York City, the pedestrians have the right of way. On the other hand, the taxis are behind you honking. So the way the human does it is you basically violate the law and you start trying to make eye contact with the pedestrians. You intimidate them, you start creeping forward, and finally you break through and you get back to New Jersey. How is the autonomous car going to do this? Venkat, do you want to?
Yeah, I'll answer that one. So I guess when I said we imitate the behavior, it's not just arbitrary human behavior, right? So we collect data from experts. So hopefully they're demonstrating good things, which doesn't involve violating laws of the road. And so this means we could be more conservative than how people might behave, but that's okay. So we want to learn from experts who satisfy these rules. At the same time, it's not just machine learning, but we subject constraints on the system in terms of planning invariance. So there are always safety constraints that are being imposed on these machine learned models, right? So that is going to capture some of your legal and safe rules.
So I could add something to that. So from my opinion, it is simply the case that the society has to change for this. It is the case that even with nowadays level 2 systems, well, if you look at the distance assistant, by law, it is actually not allowed to get shorter than a certain safety distance, at least in Germany. And which means that on this distance is so long that usually when you have the system in place, then you have always cut-ins from other cars. And because German drivers simply don't obey the rules. And this is something that cannot do anything against it. If you program it manually and say the safety distance is smaller than the legal one and you cause an accident, and I do not want to know what is going to happen with this if you get into an accident in the US with such a piece of software in your code. So this is a really difficult thing and a situation, and I truly think the society needs to change and the laws need to change, and the behavior, how people actually deal with self-driving cars also needs to change. I mean, it's going to be the case that people are going to challenge self-driving cars. We had this in Phoenix already, like people were throwing things at Waymo cars and things like that. So this is actually like something that we observe already, and there needs to be laws.
So I guess what we want to do is going to be reducing the mismatch between the driving probability, like the driving distribution of the machines, and what is the driving distribution of the actual humans. I'm familiar with how, I don't know how it works in Germany, but I know how it works in Italy. And
there are no laws.
So in Italy, when you actually go to get a driving license, they tell you this is what you had to learn to pass the exam. This is not what you have to learn for driving. If you try to drive by following these rules, you're going to create an accident because no one actually follows those rules. So it's very important not to have like a rule-based system for those machines, but it's very, very important to actually get a distribution that is as close as possible to what is the norm, no? Because again, when you drive, you're going to be driving by how other drivers drive around you, right? So if you're in New York City, it's kind of close to Italy, no? If you try to also to ride a bike, you have to learn how, the traffic situation works. And after a bit, you just, you get used to it. You're going to start honking and shouting and getting very angry. But that's part of the how you actually learn to drive there. So you were saying, would you be altruistic? Would you be aggressive? I would say you would have to tune your own driving controller policy based on the region you are, right? So you can have like a latent variable model, and then you have this latent, which is basically tuned to the location. You go to China, it's very interesting as well there, right?
Yeah, so adding to that point is that, for example, point out a concrete example. Let's say that you have a subway trains coming up, and you jump in front of the train. Is the train supposed to stop and save you? Actually, no. If somebody jumps in front of the train and they get killed, it's that person's fault. So for self-driving, it's similar. Right? If you on purposely fail the self-driving car and get killed, if the legal regulations support the self-driving car because it's not the self-driving car's fault. Let's say that we just some car accident like this happen. If once a law like this passed, suddenly I think all the parents are going to teach their children don't jump in front of the self-driving car to get suicide. So I would say that this problem, because we are in a technical community, one thing is sometimes we think about solving the problem within our capability. But at the same time, another way is we actually push out. We talk to the regulator, we talk to government to let them help us define the law, let them educate the general public. If the general public can be educated, they will adapt to this new kind of technology. Then self-driving car is not going to take 50 years. It's going to take a few years to come. So that again, I would say that this is not a fixed problem. It's not a mathematical problem. We write down the objective function, we will have to solve it. Because the objective function can be changed. If we are part of the responsibility, I would say, from the scientific community is also for us to champion to the world, to let them know that what self-driving car technology can do and cannot do, and let them work around the world, change the culture, change the law, change the behavior, how the road users are using the road, and that will help us significantly speed up the adoption of the technology.
I have to add something very, very short. I need to apologize to our Italian friends. I once read that the Italian city Palermo is one of the safest traffic cities in Europe. And the reason for this is that Palermo is so packed that the average velocity of vehicles is literally 0.
So I have another question regarding human behavior understanding, right? So a lot of you have perception, prediction, planning. Prediction is hard, especially about the future. So it's understood that prediction is one of the most challenging problems. We talked very briefly about pedestrians, so maybe that's a question for Sven, maybe also for Alfredo. What do you think in terms of what are the open research challenges, if there are any, unless it's just the engineering executing challenges, but are there any open research challenges in your opinion for understanding behaviors of humans, pedestrians, but also in the car when people wave at you, you have right of way, they have right of way, but they will lead you do the unprotected left turn. So these kind of challenges, what do you think are things that are beyond just the engineering capabilities today, if any?
What are the challenges? Well, as you say, it's one of the hardest. Everything from finding the right representation of how you read people to the whole breadth of human behavior in the context of where they are. There are various ways to go. There's kind of a Pareto curve of how much data do you use and what is kind of model based and what do you assume, and kind of how much do you reduce your input representations to then do very easy reasoning, or how much do you keep the maximum information and then do kind of a full data-driven model. kind of, from the representation to how to exactly do the prediction to at what scale you do it, it's kind of, I don't think we have an answer. And kind of, I tried to give today kind of opposite to what most people present, that kind of the full data-driven way, a model that is very kind of hand engineered and has a lot of assumptions built in, that also gets us very far in some aspects. But I don't think we have the solution exactly given the amount of data that we have now or that we will have in the future, and what's the right model for that. I think that's an open question.
I want to follow up on that. Yeah, I think among all the AI stack, all the AI in the autonomous driving stack, prediction is the one place surprisingly have very few literature. If you think about object detection, tracking, or planning, motion planning, decision, or even control, they have a lot of literature. It's very well studied in academia. The only thing that is not very well studied is object prediction. Like how do you predict in the following 10 seconds? What is the trajectory? What is the intention of the object? I think one difficulty of I think a lot of people in academia is very, very smart. I think the problem is not because we don't have enough IQ for this problem. The problem is more about studying this problem is very difficult. Studying this problem requires you have a lot of support. You need to have all the object detection system in place, tracking in place, LiDAR, camera, radar, fusion in place. You need to have HD map in place. You need to have the localization in place in order for the prediction model to get all the input. The prediction model requires all this input from different components. I think except probably around 10-ish the top tier self-driving car company, all the other places in the world, in particular in the university, there's no resource to gather all this input. They cannot even start the experiment. I think that's one of the biggest problems. That's why there's so few papers published in this area. It is such an important but actually unresearched problem. So I would really encourage everyone sitting here to try always. Yeah, it's true that it's difficult, but there's a way to collaborate with company, do internships, and do joint collaboration, get that data. That will be probably help to accelerate this area.
So one word that was reoccurring a lot, it's safety, but it's not really clear what people mean when we mean safety of autonomous systems, or autonomous cars in this particular case. So, more classical engineering has had this history of having standards, typically ISO standards, that ensure that a tool or a system is safe. And that's now quite well sort of accepted framework. The difficulty with autonomous systems is that there are these systems interacting with the environment and perceiving the environment. And now the safety is becoming a function of the environment. So, the typical standard framework would be that, the tool has to have a smaller, there's been certain probability of failing, but now this probability becomes a function of the environment. So it's interesting from your point of view, how you think about safety and safety evaluation, what it means for a car to be safe, that can be deployed and can be sold. Does it mean, because since it's a function of the environment, does it mean that certification has to be in every different town is going to operate in, or do you think there could be other approaches that you can, sell a car that hasn't been certified in a particular environment? So it's an open question.
Herman, do you want to take that one?
Well, indeed, that's one of the most complicated questions today. Actually, if you talk to legislators like NHTSA or DOT, like they have, or even in your MCAP, like they have this question. Definitely, I think there was a good point there. Like you need to account for the environment. So safety metrics are going to be defined in terms of environments and situations. Something like, I don't know in the end what kind of metric is going to be adopted. I know that people have been proposing at least 3 or 4 different metrics that are gaining in popularity, one of them being RSS. One of the important things to notice is not about failing or not failing in a given situation. Like not failing is not good enough. Like being about to kill someone is not good enough. like you need to define, you need to actually define some real boundaries that are considered safe. What are going to be those boundaries? That's not clear yet. So we need to work harder on standardizing these metrics. We need to start analyzing these metrics in different contexts, and we need to see their value. I think legislators and also companies will start making a huge effort for start adopting some of these metrics. So far, there's no answer.
You want to talk about that in terms of guard? Okay, good.
Another aspect of safety I think we need to consider is not just whether we are safe with respect to the environment, but also are we perceived to be safe with respect to other humans. So we might be completely safe in the environment in terms of avoiding obstacles and doing all the right things, particularly with respect to the law. But if other humans cannot really perceive what our intention is or what we are planning to do, then it is still an unsafe behavior which we somehow need to incorporate into our vehicles. So for instance, in a crosswalk, if a pedestrian is waiting for us to go, but we are not able to sort of convey to the person our right intention just because we are very different from how a human conveys its intention by either like signals or other mechanism, then it should still be perceived as unsafe and might still lead to issues further down the road.
You want to take that?
Maybe a side aspect to this is when I mentioned this morning that we have problems estimating distances of people. If you sometimes you want to call like a self-driving car system safe if you save a certain number of people. If you save 3 people, then it's a good system. What I would be worried about with some of these systems is that you don't save 3 people, but you save 7 people, and you kill 4 others, and you have a bias, and it's only a certain type of other people that. So just a simple number of how many people you've saved is sometimes difficult with these kind of systems that do make very systematic decisions about in the environment with respect to certain people.
Yeah, I think also again, like we need to carefully think about this. In the end, we want to make the world a better place, and there's like all these like car companies are right now working towards reducing the number of fatalities per year. That's actually the goal of, and this is not only like by changing cars, also by changing the environments and so on, like these roundabouts, and that's all measures in order to reduce fatalities. But they cost maybe others, maybe other fatalities. It's hard to measure and hard to predict. And I think this is something that we should definitely like approach in a certain way, and we should also have measures for this. The same is with every technology that we introduce. It might even be that a guardian functionality that saves the driver in one case, but does not save him in the other case. Humanity has done this in various ways by introducing cars, like for the luxury of being faster in our movements. Like we kill millions of people per year, and somehow our society is willing to accept that, and that's something that we need to rethink. And in the development of self-driving cars, at a certain point in time, we need to decide as to whether the benefit for the society overall is higher than the fatalities that come with it, with the change that we introduce.
Maybe can I just sort of one part of the question was about is safety being a function of the environment and this place, and sort of thinking does safety means testing in each environment and only then being released from or what do you think about this, or is this transfer of domain, or it has to be tested and safety validated in each environment? So could you elaborate on this aspect as well?
Yeah, it depends. Depends on how you define the standard, right? If the standard is just a minimal risk condition, then it's not necessarily it's a function of environment. Right? For example, you can set the minimal distance to any object is 0.5 meter. In that scenario, it's not really depends on any environment. Right? It's just what the car has to maintain. No matter where you drive, what happened, it will maintain the minimal distance to any object of at least 0.5 meter. So it really depends on how you define the safety standard. Yeah, so there's no easy answer to that question.
But still, I could imagine that an approach like CALR would be something that the car driving community could actually utilize in order to perform tests, so that we actually have standardized sets or randomly or some sort of a generator for situations that that is used in order to validate cars in certain situations, right? On top of other measures. I mean, it's going to be extremely hard to exclude, even when you think about safety critical components like an autopilot. Even those had errors, right? And it's extremely hard to verify them and foresee all situations that a car or an airplane might encounter.
So I guess I just want to add on. So the question was on how do you test systems with varying environmental conditions? I think there's a broader notion of safety. So your computers could fail, sensors could fail. There are really all kinds of failures you need to consider in analyzing safety. And this is something which the airline industry has been doing for a lot of years and decades now. And we need to be doing the same thing in our systems. How do we build redundant computers, and analyzing all of that in that context? And so I guess I want to point to that as one of the key differences between L2 and L4. The numbering makes it seem as though you can step along this ladder and you'll be in L4 in no time. But really, there are very different problems you need to be solving to get to level 4, and which involves thinking about safety in a very broad context.
So I'd like to add something. Back in the 80s, I think we had like 1 death every 10 minutes in the United States. So there were like 50,000 deaths per year associated to driving cars. Now we are in 2020, we have roughly 1 death every 20 minutes. So we just went double the time. Still, every 20 minutes, 1 guy or a girl will die. If we can do better than this and we go from 20 minutes to 30 minutes, I think it's actually a gain. So although, you're talking about accounting deaths, which sounds kind of, weird, but again, if you improve this kind of metric, I think is actually a good thing.
To Sven's point, what if you suddenly don't kill adults anymore, but you only kill children? And you are at 1 death every 30 minutes. Is that a benefit to society?
Yeah, that's a good point, because basically what that's telling you is like just trying to minimize some metrics, not that you actually need to define what you want to care about, right? You really need to make definition about what's the value of different type of life. It's not just about minimizing or maximizing a metric. We need to actively define among all of us, like, we care about this. So the approach that we have been following so far, like, well, just let's keep playing. At some point, things will improve, and we just need to see that we decrease fatalities. So that's not good enough. Yeah.
Yeah. So basically, to the point of the gentleman, if you evaluate in a statistical fashion, right, and you say, like, for instance, one thing that I regularly say is that we should have much bigger test sets. But the world is non-stationary. So your self-driving car is not a self-driving car. It will have to be a self-learning car, right? That will continuously learn. But if the way we evaluate in a statistical fashion is by defining, when you deploy, you don't have experts anymore. So you will have noisy demonstrations. You will have noisy behaviors. So you'll have to label them, right? If you don't explicitly request demonstrations. So then humans will have to label constantly data to evaluate systems as they get updated. Is that the only way? And if so, maybe it's better to just drive and be better drivers.
I think it's actually it's probably going to be the only way. And to my understanding, that's actually a good idea, because then instead of driving there, you can sitting in a nice office and with a cool AC, and then with a few mouse click, and that's you do the job. You earn the same amount of money. I actually, because labeling is becoming a huge industry. There's actually many companies in many countries, even in Silicon Valley, there are many stars just becoming a label data. So I will say that this is really become the new factory in some sense, the AI age factory. I think New York Times actually have a front page article about covering that industry. It's a very interesting industry. Is the unnamed hero behind our AI revolution.
They call them data curators.
Yeah. Take one last question. Is there a question there? Yeah.
Hi. Actually, I'm from the OEM side. Right now, each year, global-wise, we have 80 million new car coming. Actually, and also I believe all the OEM want to catch as the Tesla, like the we call level 2.5 or level 3. So the question is right now, from today the whole day and CVPR the whole week, right? I believe the perception part or other, for example, planning part, there's the algorithm is changing. Yeah, there's a new thing coming, and also, but the problem for us is, so we don't want the whole stack is changing. For example, currently, so we use based on the cost, so we use some of the chip, hardware board, the kernel, embedded system. But on the top level, for example, for the perception planning control, right now, control part is a little fixed, especially in level 2.5, level 3. And for example, the fusion also kind of fixed. So actually, so my question is for perception, especially for the vision part, right? And do you think it's currently, can you get, or do we have some platform, do we have interface or platform to define, to let we have fixed or some the fixed stack, but at the top level, some, for example, the signal network, some backbone, that can be keeping changing. But for other things, for example, some ISP, the computer, the CV part can be fixed. Then so we can put in our product, then we can update the backbone wherever you should have a new one. Yeah, so question is, do you think currently perception or some planning part, is there anything, so we, for example, for level 3, yeah, so we can be fixed, then we can define to let a professional company to have the product and go to the mass production. But for other part, we can use OTA to update, yeah, something like that.
I think for control algorithm, the reason it's fixed is because for many years, control community has done a good job to have very reliable algorithm, either it's PID or model predictive control MPCs. Those algorithms are very mature, and also because it's less about AI, but for perception and prediction and also planning, a lot of them are more about AI. For those more AI related area, the field is still making a lot of rapid progress. Like for example, even in sensor fusion, I don't is fixed. I think different companies, including us, have different fusion technology. There are a lot of technology about how you fuse the camera, LiDAR, radar, all different sensors together. This is still ongoing research. I believe that in the conference, there are many paper publishing still. But this is part of the interesting part, is right? That's what keep everyone here be very busy today, is to research better algorithm, to engineer better algorithm. But while they are changing overall, I would say the general direction is quite similar, at least among the top tier players. Everyone, I'm pretty sure everyone is using convolutional neural network. Everyone using a lot of machine learning. So the general direction is fixed. It's just like we all have these tools, like either imitation learning, convolutional neural network, deep reinforcement learning in our tool set, and then the way we use those tools may be different. And from the OEM perspective, I think we can certainly provide a standard interface for perception output, for example, that for each object, what is the size, the location, the orientation, the speed, the prediction in a consistent format. That's certainly doable. But for the actual algorithm, again, I feel that rely on OTA is probably a better idea.
Anybody else want to pick up?
Yeah, just to add on to that point, I think for a lot of the perception planning parts of the pipeline, it's not only that we cannot at the moment fix these parts of the pipeline, but I would like to advocate that we actually should not be fixing these parts of the pipeline right now, because at least in the current state, what is state of the art right now, these algorithms are all very preliminary in my opinion, and like no one has really agreed on what is the best approach to take. Everyone has a different approach, and even though we use a lot of the same backbone to all of our approaches. The backbone is like really far down in the fundamental pipeline. Like it's convolutional neural networks, which is a really fundamental algorithm. It's like the way we build on these algorithms is all very different. And that's actually a really beautiful thing about where we are in this like search for an autonomous vehicle controller, or like in the development of autonomous vehicles right now. That's a really beautiful thing because we haven't converged on what the best approach is. We're trying so many different things. We're not sure what's going to work best. And like we should actually embrace that fact, and we should not like fix these parts of the pipeline because we don't know which part of the pipeline actually is the best right now.
I want to take the opportunity to give the last word. My own belief is that even fixing a notion of a particular pipeline is probably a mistake. And I made that mistake myself when I ran a program in DARPA called Logger about 15 years ago. And there I had CMU create a driving stack for off-road driving with the replaceable modules. And the notion was that the participants in the program there, I think there are about 6 or 7 different, mostly university teams, could replace individual modules and but keep the other parts. They wouldn't have to create the entire driving stack. But it turned out that the selection of just breaking the problem down into those modules was too limiting, and it didn't allow people the freedom they needed to really innovate. And in fact, a seedling program for that was work done at NYU, and also a company called Netscale is mostly Urs Muller and Jan LeCun, where they started the work on the DAVE project, which was end-to-end driving, and that idea didn't fit into the stack that we got from CMU, and they had to put that aside and go back and sort of do a more traditional approach. And the end-to-end stuff didn't get revived till about 4 years ago. So there's a danger in even freezing the whole notion of what the architecture might be. So with that, do you want to respond?
I want to add something here. I completely agree, because there's actually evidence, and there are some papers out already, that when you, for example, take networks that solve multiple tasks at the very same time, right, that they get better in all the individual tasks than you could become with one individual network. So, for example, if you combine localization with semantic segmentation, then you get better in semantic segmentation and localization, and you outperform both individually trained networks. And this is an indicator for the fact that what we are doing right now is probably, from a logistic point of view, the best thing to do with different kind of implementations. If we had 20 more years' time, then we would maybe go for the holistic approach and solve this in an end-to-end fashion and get some epsilon better.
I want to thank the panelists, and I want to thank the attendees for, I think it's been a great day, and I hope we can get together again in a year and see tremendous progress. So thank you all.